Hello everybody, this is paper 1 from May 2023. This is time zone 2. Let's go on to question 4. At a running club, Sung-Jin conducts a test to determine if there is any association between an athlete's age and their best time taken to run 100 meters. 8 athletes are chosen at random and their details are shown below. So we have different athletes from A to H, or 8 total athletes. You have their age and the time it took them to run the 100 meters. Sung-Jin decides to calculate the Spearman's rank correlation coefficient for his set of data. Complete the table of ranks. So let's look at the time rank first, just because they give us the value of 1, and that should usually give us some kind of indication of how they want us to rank these values. So we see 1 corresponds to the longest time, and so let's go from longest to shortest. One other thing, 2-mark question. There's only 2 rows, so it suggests that there's going to be no ties, for example, and we're just looking for straightforward rankings. So from highest to lowest, this would be 1, 2, actually sorry, after saying that there is actually a tie right away. So we see these 2 values, 13.4, 13.4, and they both can't take the 3rd position, they both can't take the 4th position, so what we do is they share the 3rd, 4th position. We average this out, and they both share 3.5. So this would be 3.5, and this would be 3.5 as well. So here's the 1st, 2nd, and then this is the 3rd, 4th, where they share this position, and after that we would continue on, and this person number H, would be the 5th longest, or had taken the 5th longest time. This would be 6, 7, and 8. Okay, so for ranking these from longest time to shortest, let's rank the age from oldest to youngest as well. So this would be the oldest person right here, and this would be the 2nd oldest, 3rd oldest is already given, then we have the 4th oldest, the 5th oldest, 6th oldest, 7th, and the 8th. Okay. So a little strange that it's only 2 marks. Usually there's 1 mark per column and then 1 mark for recognition that there is some kind of tie here. Alright, part B asks us to make use of this table and asks us to calculate the Spearman's rank correlation coefficient, RS. Okay, so to work this out, we're going to go into spreadsheets and run 2 variable statistics. So let's go back to the document. Here we are in the calculator spreadsheets. Let's label X and Y. We could put A and T, age, time, but doesn't matter so much in this case. Let's put our values in. In this case, to find Spearman's correlation coefficient, what we do is we put the rankings in. And we calculate this correlation coefficient just as we would Pearson's, but instead of putting the actual values, we put in the rankings. So this is athlete A, they were the 7th, athlete B was the 6th, athlete C was the 3rd oldest, and so on and so on and so on. And so we put our rankings in, and then we match the coordinate pairs. So if this was the 7th athlete, or athlete A was the 7th oldest, the 7 matches up with 3.5, 6 matches up with 2, 3 matches up with 3.5. This athlete D, for example, who was the 5th oldest, took the 6th longest, and so on and so on. 1 and 5. Alright, so let's go ahead and statistics, stat calculations. And in this case, we wanted to 2 variable statistics. We're comparing these 2 variables of age and time. So we put X within our X, Y within Y. That's all we need. And here we're going to look for R, our correlation coefficient. And there it is. Negative 0.6706 or 0.671. Negative 0.671. So let's go back to the document and write this out. Our S is equal to negative 0.671. 7, 1 to 3 sig figs. Okay. C. Interpret this value of RS in the context of the question. So whenever they write context, even though it's still just a 1-mark question, they're looking for specific mention of these variables. So in this case, we can say there is a negative correlation or there is a negative association. There is we can say, a moderate negative correlation between the ranks between, let's say, age and an athlete's time to complete 100 meters. 100-meter sprint. Okay. Part D. Let's go on. 1-mark question. Suggest a mathematical reason why Sung-Jin may have decided not to use Pearson's product moment correlation coefficient with his data from the original table. So why he did not want to use Pearson's. So remember, Pearson looks for linear correlation, where Spearman just looks for an increase in one variable is associated with an increase in another variable, increase or decrease. So a few different things that we could say for part D. We could say that Spearman is less sensitive to outliers, for example, which it is. Less sensitive to outliers. The most common or most likely would be to say that perhaps relationship may not be linear, and Spearman gets around that just because it looks for what's called a monotonic relationship. That is to say, increase in one variable is an increase in another variable. Relationship may not be linear. So really maybe he's just looking to see, as age increases, does time increase? Not necessarily a linear association, but just as one increases, does the other increase?